Alright, John, there's only 4 more questions that I want to go through on the practice test with you, and then I'm going to let you go. Alright, so number 12 is express cosecant theta minus cotangent theta times cosine theta as a single trig function. So it's kind of similar to what we just did, except for this time there's no squares going on. Whenever you see a value that's being squared, more than likely it's going to have something to do with one of the Pythagorean identities. When you don't see anything squared, really all you need to do is rewrite everything in the problem and express it in terms of just sine and cosine. Okay, anything that you see within these equations can always be rewritten in terms of sine and cosine. Sine and cosine are our most basic elements. So how can I rewrite cosecant theta in terms of sine and cosine? Well, that is actually just 1 over sine theta minus, let's just go through everything and then figure out what we need to do. Cotangent theta is cosine theta over sine theta. And then cosine, we can't really simplify that any farther, it's just cosine theta. Okay. So I can simplify this a little bit further. I can rewrite it as one single fraction because those are being multiplied together. So this is 1 over sine theta minus cosine squared theta, because cosine times cosine gives me cosine squared, all over sine theta. Now, multiplying and dividing are always the easiest because you can always just cross things out. When you're adding and subtracting, you need to make sure that you have a common denominator. So in this case, I do have a common denominator. There's a sign here and there's a sign here. So that means that my numerator becomes 1 minus cosine squared theta all over sine squared theta. Or I'm sorry, just sine theta, not sine squared. Now, whenever you see a 1 minus either sine or cosine squared, you need to be thinking of a Pythagorean identity, because we know that sine squared theta plus cosine squared theta is equal to 1. So you remember how there were 2 different forms? We could rearrange this equation and kind of solve for sine or solve for cosine. So if I see 1 minus cosine squared, so if I do 1 and then subtract the cosine squared from both sides, then these cancel and you can see that 1 minus cosine squared theta is actually equal to sine squared theta. So on the top of this, that whole numerator becomes sine squared theta divided by sine theta. And these work just the same as any old variables. If I have a sine squared on the top and a sine on the bottom, I can kind of just get rid of that, and I'm left with just sine theta. Alright, so all the way up here, this whole thing really was just equal to sine the whole time. And we're going to do a unit where we actually do something similar to this, and it's in the form of proofs. So this is something that you are going to see a lot. Okay? That was number 12. Number 13. We need to take this fraction, sine theta over tangent theta, and rewrite it in terms of cosine theta. I'll read the whole question to you. It says, transform sine theta divided by tangent theta into an equivalent expression in terms of the trig function cosine theta. And the reason why they're saying in terms of cosine theta more than likely is because your answer at the end is going to be equal to cosine theta. But sometimes it's cosine squared, or maybe it's 1 minus cosine, so you can't just write cosine as your answer once you see that. We need to see all your work in order for you to get full credit. So I'm going to do the same thing that I said before. I'm going to rewrite everything in terms of sine and cosine. So on the top, sine, I can't rewrite that at all, but what I am going to do is write it as a fraction, because I know that the bottom tangent is going to turn into a fraction as well. So sine is sine over 1. Tangent is sine over cosine. Okay. Now this is what we call a complex fraction. I have a fraction divided by another fraction, so in order to simplify that, I'm going to multiply by the reciprocal of the denominator. So the reciprocal of the denominator is cosine theta over sine theta. And I have to do that on both the top and the bottom. And I'm multiplying right now. Cosine theta over sine theta. Okay, so everything down here cancels out, and up on the top I'm left with, I have a sign in the numerator and a sign in the denominator, so those cancel, and this whole thing is really just equal to cosine theta. So you can see that it said, you know, rewrite it in terms of cosine, and the answer was cosine. So sometimes that happens. Okay. Excuse me, sorry. Alright, there's 2 more questions left. Number 14. It's pretty much the same thing. You need to take the expression tangent theta divided by secant theta and just rewrite it. And this one is a multiple choice, but you still have to do all the same work to get to the answer. So same thing, I'm going to say it again. Rewrite everything in terms of sine and cosine. So tangent is sine over cosine. And if you don't have your thetas written out on this test, Ms. Tompkins is going to take off a lot of points. Okay, so just make sure that you're writing theta after every single one of these functions. And then secant can be rewritten as 1 over cosine. Same thing again. This is a complex fraction, so I need to multiply by the reciprocal of the denominator, which is cosine theta over 1. Everything down here cancels out, and you can see I have a cosine here and a cosine here, and this whole expression is just equivalent to sine theta. Alrighty, and last question. Number 15. The expression 1 plus cosine x times 1 minus cosine x is equivalent to what? And then it's a multiple choice. So these are 2 binomials being multiplied together. So you can think of FOIL, you can think of Punnett square, any way you want to do it. I FOIL. So 1 times 1 gives me 1. 1 times negative cosine x is a negative cosine x. 1 times positive cosine x is another positive cosine x. And then positive cosine x times negative cosine x gives me a negative cosine x, or cosine squared x. Okay? These terms in the middle cancel out, and I'm left with 1 minus cosine squared x. And just like I said before, whenever you see sine or cosine and it's squared, and you also see a 1 there, you should be automatically thinking Pythagorean triple. Let me just rewrite that for you one more time. Let me see how much time I have. We're good. Sine squared theta plus cosine squared theta is equal to 1. So if I have a 1 minus cosine squared x, or theta, or whatever, that means I subtracted this cosine over to the other side, and 1 minus cosine squared theta is equal to sine squared theta. So this whole thing is equal to sine squared theta. Okay? Or x, whatever. And that was multiple choice. Okay, so let me see. Hopefully if you have that practice test, you were going through it with me. If not, I think that you probably have a pretty good indication of the stuff that's going to be on the test now. If you think you need more practice, that's fine. Just ask me and I'll come up with questions for you. If not, I would ask Abby if she has both the Chapter 10 test and the Chapter 10 quiz. And I would like you to take the quiz first and then let me know how comfortable you are with it. and then I want to talk to you about like maybe one more thing before you take the test. So I do want to talk to you before you take that test. And you need to be working on all the homework assignments that you're missing and getting those into me. Also, your classmates are currently handing in their final 5th portfolio. I believe maybe that you have one of them done, and hopefully you should have the other ones with you. I just submitted, I think, the final one to you. Abby should grab it out of the folder, so I need you to be finishing all of those portfolios or working on the ones that you do have and asking me questions, because those 5 portfolios plus your midterm grade actually account for a lot on your final average. So you need to be working on those. Okay, so I'm going to go. I'm going to leave for Ohio in a couple hours. Hopefully I can Skype with you. Hopefully you feel better. I'm sorry you don't feel very well. And text me if you have any questions. Okay, see you later.